I just would like to say thank you very much for Kyoko invite me come over to speak in the high myopia section. Today, I'm going to briefly share with you an idea to develop a whole eye system, in particular in the context of high myopia. This is conflict of interest. In particular, the last one is a file patent that relevant to the technology I'm going to mention. So I start from our high myopia registry study. So this is a 10-year study. We initiate in 2012, and now we already finished the final visit, 10 years visit, high myopia registry. We enroll this 7 to 70 years old patient, sphere only minus 6 diopters or greater. And one of the experiments we work on this particular cohort is we invite this high myopia patient, high myopia participants to receive MRI scan. So this is a paper we published a couple years, like 7, 8 years ago. It demonstrated actually the ocular shape among the high myopia patient. First of all, the ocular shape is really associated with we call it the pathology myopia grading. So shape is important. That's all we know. So the idea is that having my MRI scan done is very painful. It's expensive. It takes a long time, like 30 minutes, 40 minutes to complete. So the first question is we ask is whether we are able to convert a 2D, two-dimensional, like 2D fundus photo to a 3D MRI photo, MRI ocular shape. So the second question is, can we predict the ocular shape change over time, in particular in a high myopia patient? So this from image to image translation, or the GAN technology, generative AI, we have done some experiment before. So this is one of the experiment we demonstrate that we can convert or translate a full color fundus photo to fluorescing. So as you can see from these images, this is diabetic patient, obviously. In the fake or generative late phase FFA, you can see this neovascularization leaking. So this is really consistent with the real FFA. So that study demonstrates that converting using the GAN technology, generative AI, you are absolutely able to convert a full color fundus photo to a fluorescing images. And then we are able to observe very similar pattern on the ischemia in the retina, and also neovascularization leaking, and also the microaneurysm changes as well. So the question is, are we able to convert directly GAN technology, generative AI, to convert a 2D full color fundus photo to ocular shape, MRI 3D ocular shape? The answer is no. This is not possible. But then it might be possible if you add more information, more, we call it multi-modality data. Like, for example, the metadata. If you tell the AI what is the axial length or what is the spherical equivalent, combining the fundus photo with the metadata, we might be able to generate MRI ocular shape image. So this is how we develop this segment anything mode that you can easily segment the ocular, the eyeball from the MRI scan, and convert it to a low resolution 3D images. So I'm not going to go through the technical detail. But then again, we need two input. One is the fundus, one is a fundus photo. Second is a metadata. We combine these two into the model, and then we develop a technology that can automatically segment the MRI ocular eyeball from the MRI scan, and then this will generate a 3D view, 3D eye ocular shape image. So then we use this two input to generate a 3D image, 3D ocular image, compare with the gold standard. So we have a GAN technology. So we need to treat, or CHEAT, treat the AI until AI cannot differentiate the generative 3D image and and this is a real or fake, I mean generated or real 3D images, then we establish the neural network. So with this technology, we demonstrate that using this a spherical descriptor as a parameter to assess the accuracy of the on the generative ocular 3D images. As you can see from here, we can put patients into 3 categories. One is no staphylinoma, no ocular shape changes at all, eye myopia, like a round shape. And then you can see this this is the gray, the dark light color one is the real one. This is ground truth, and this is a synthetic, like generative one. You see this, they are very similar. And then, but then there's also another category is with staphylinoma affect the macular region or posterior pole. Then we also observe from different view. This is from the, I think it's from the this different view on the 3D image. You see they are very similar to each other. The real one and the synthetic one. And this is the more severe staphylinoma group. And then again, they're very similar. But then we also look at the compare the, this is called chamfer distance. Chamfer distance is a parameters that indicate how close is this 2 3D they call it 2 3D point set. 3D, there's a point set. So generative one and the real one. So with the chamfer distance, we demonstrate actually quantitatively the generative 3D image and the real 3D image, they are very similar. And then we also develop a technology that can simulate what when we change the metadata. For example, we change the metadata, the axial length, or not the diopters from -5 to -10. What is going to change? So this will be able to simulate if no treatment, when the patients have a progression on the high myopia, what the ocular shape looks like. So this is we call it counterfactual generation. So we can simulate when the degree of myopia increase, how this might change the ocular shape over time. So this is a good way to scare your patient. If you don't treat if you don't ever receive the treatment, so your ocular shape will become very terribly look. So then we also perform. We look forward to collaborate with you, for example, to validate this model. The model is like you only need to tell the model fundus photo and also the axial length equivalent, and then we will be able to generate the ocular shape for you. So then we call it fundus to globe. And also there's another, we're also working on a technology that can use fundus photo to generate fundus OCT images. So this is fundus to OCT generation. So the question is, are we able to combine the ocular shape, MRI ocular shape, and also the OCT scan? Like for example, and then first of all, we develop a high resolution technology, a methodology that you can collect a high resolution T1 MRI image. You can see the T1 image on the highly myopic eye can be, now you can see the MRI, the resolution is much higher than ever before. So the idea is how can we combine the ultra wide OCT images and using the MRI scan as a ground truth to train the model, develop a whole eye, like a whole eye OCT like this. You can see the schizoid and the ocular shape. This is the same patient. The ocular shape on the posterior segment is very similar to the MRI scan, and also we can demonstrate all these OCT histology changes on the eyeball as well. So at the moment we can do half of it, and later on I will show you the whole eye, OCT, whole eye OCT data. So and then in conclusion, when you compare, the MRI scan is very expensive, take a long time to complete, and then it's just only allow you to do static assessment, and it need to be in the MRI clinic. But then with our fundus to globe, very cheap, and less than 3 minutes, and also it can simulate what you're going to look like, the ocular shape. And then now we are able to also combine this ocular shape with the OCT data, you can see how eyeball, the whole eyeball will look like in the future. So we are looking for researchers to collaborate on this particular project, and then in Hong Kong Polytechnic University, we developed this RCSV as a research center, dedicating for new solution and product. Every single of our researcher, fellow, they're working on different products and solutions. So you're welcome to collaborate with us. Thank you so much.
Min, a great talk with stunning images. Can we have some questions? Yes. Are there any questions, Tomo?
Thank you so much. So this is a wonderful presentation. I also have the study about the 3D MRI. So I have one big question. So the 3D MRI image is the external information, and the color from this photo is the internal information.
Correct.
And the OCT is the midst information, I think. So I'm not familiar with the AI model. So can you do the, your model is a mix of the external and internal information, but can you do the mix of these three information to the one? So I mean, if it is possible, we can get the comprehensive information at just one AI model.
Yeah, this is a great question. So this is really what we try to achieve in a couple months' time. So as you can see from this image, we try to develop a technology that you can combine the OCT scan and where you don't have to, first of all, you don't have to do MRI scan at all. We based on the fundus photo and also OCT, we can generate the ocular shape. But then the ocular shape is external. But then the challenge is that we also use a T1 image, as you can see here, MRI T1 image. The T1 image, you can perfectly see the ocular, the eyeball, like the wall, the shape, and also the wall, external and interior surface of the ocular wall. So with this information, and then also a unique solution in the OCT scan, you can reconstruct the whole eyeball, like with both information on the ocular shape, but also the internal changes. Thank you.
Yeah, thank you so much. Other questions? Yeah, Raja, please.
Thank you so much for the wonderful talk, Dr. He. When you talked about scaring patients, and patients are really scared about what would happen to their vision in the future. So when you mentioned about the OCT being generated by AI, by a combination of fundus photo and MRI, have you tried to look at specific changes in different layers of the OCT which can be predicted? Because I believe Brooks membrane and choriocapillaries are so crucial in terms of the visual outcomes in the future. So have you tried to look at, based on fundus photo and MRI, if you generate an OCT, which patient is likely to have Brooks membrane changes or choriocapillaries atrophy?
I agree with you. Because the idea of our whole idea is to develop a whole eye OCT. So with the OCT image, you can see all these structural changes, including the Bruch's membrane. But also you're able to see these tractional changes. Tractional, like this, which is the tractional change. Because I believe the retinal membrane and also the richest traction is more important in terms of like generating this high myopia damage, like schisis and all these problems.
Yeah, it's an important point you made, but I think as of now the epiretinal changes, we still have some surgeries to offer, but for the other changes we don't have any good treatment right now. So, so I'm just curious, you know, so it can look at all the retinal layers.
Yeah, all the retinal layers, choroidal thickness as well. Yeah.
Thank you so much.
Thank you.
Yeah, sure. Thank you so much.